Welcome to Age of AI, Politics, Law, and Society, hosted by Medler Mema, Chris Lamont, and Young Diogenes, in association with the Global Governance Institute in Brussels.
Hello, I'm your host, Chris Lamont, joining you with our guest, Ritwik Gupta, a PhD student at the University of California, Berkeley in both computer vision and public policy, focusing on computer vision in chaotic environments, such as disaster response, national security, and the dual-use nature of AI for both civil and defense affairs. Ritwik is a member of the Berkeley AI Research Lab, a graduate fellow with the Berkeley Risk and Security Lab, a research fellow at Berkeley's Human Rights Center, and a fellow at Berkeley's AI Policy Hub. Today, Ritwik joins us to help us make sense of China's DeepSeek R1, which was released in January 2025, shortly after the Trump administration's Stargate AI initiative announcement, which had promised $500 billion in investment in expensive and energy-intensive AI infrastructure in the United States. DeepSeek made headlines as a rival to OpenAI's ChatGPT, but was created at a much lower cost. So some questions we'll explore today are, what does DeepSeek mean for the AI industry? Have AI global governance discussions been led astray by the likes of OpenAI? Or is DeepSeek less of a Sputnik moment than it has been made out to be? And of course, we'll look at U.S. policy responses to DeepSeek. Welcome back to the show, Ritwik. It is a pleasure to have you with us again.
I'm excited to be here, Chris. Looking forward to the conversation.
Awesome. In that case, then let's go ahead into the first question about what DeepSeek really means for the AI industry. Of course, we've seen a lot of conflicting takes on just how capable DeepSeek is, from gimmicky to on par with the best models coming out of the United States. What is your take?
DeepSeek is a very capable model, and it certainly is on par with OpenAI's O1 in many cases, though obviously certain benchmarks show DeepSeek R1 significantly behind O1's capabilities. At the same time, as a completely open source model developed under a regime that is supposedly suppressed in terms of its ability to produce such AI models, it's a laudable achievement, and one that has been driving a lot of investigation and retrospection by the American AI industry as to how this happened, what they can do going forward to maintain their dominance, as well as what the next steps are going to be for the Chinese to keep this momentum going into future innovations.
And speaking of future innovation and sources of it in the AI industry, does DeepSeek fundamentally challenge some of the assumptions behind AI development that have been touted by some of the big players in the tech industry in the United States? For example, that we need ever-growing computing power and energy demands costing in the billions to fuel further innovation in this field.
I think so. I think that a lot of your frontier AI labs, the ones that have been showing that scaling gets you everything you want, are fundamentally threatened by DeepSeek's advancements here, because they supposedly did this with a limited amount of compute, with a limited amount of budget, and instead maximize their outputs by software innovations rather than innovating in terms of the amount of GPUs used. There's really two strategies that I've come across in this space. There is the American strategy, which is we've demonstrated with transformers that the bigger you make them and the longer you train them for with more data, the better they get. And this is generally something that holds true on a log scale. And so rather than necessarily investing in raw engineering talent, which might be able to optimize your machine learning models for the hardware that you have, you can instead then just buy more of the hardware and better iterations of the hardware and automatically do better. The alternate strategy, the one that I've seen China pursue, is to make the existing hardware work better. A lot of our leading machine learning models, right? A lot of the transformers, I should say explicitly, are barely utilizing our hardware to their maximum potential. We monitor something called MFU, the model flops utilization, which is how much of the GPU's max capacity is actually being used to do model relevant operations, right? As opposed to just shuffling data or some of these other things, pre-processing data, et cetera. And it turns out that a lot of these models, like these LLMs specifically, have an MFU of like 30 to 40%. And so the Chinese strategy has instead been, given the fact that we have worse hardware, given the fact that we might even have fewer of that, just less of that hardware, what if we instead invested in talent who can build software and models that better utilize that hardware. And clearly that's been working as well. And so I think that's where this giant step back comes from. The entire American investment thesis of give me billions of dollars to scale, and that's the way by which you win, has shown to have another side now, a side that I think was previously discarded or ignored by the investment community and is now clearly coming to the front page as like, this also works. Now, simultaneously, because this is in many ways a financially existential threat to a lot of these companies, and in general, the American strategy at large, there have been questions raised about whether or not DeepSeek did adopt that talent strategy or they adopted the scaling strategy. And honestly, like I haven't seen proof from OpenAI and Microsoft and Azure that like there was impropriety or like they were using GPUs if they say they don't have. And so really a lot of the finger raising that's been pointed at DeepSeek seems to be disbelief rather than necessarily well-founded truth. And that's not to say that China hasn't been smuggling GPUs and that they haven't been finding ways to get around the limitation of hardware that they found. It's just that to me, it feels certain, like some of it seems disingenuous as like we simply cannot believe that our thesis is wrong and there's another valid thesis to pursue here as well.
So OpenAI has effectively also alleged that DeepSeek has stolen a lot of their own advancements in AI to create DeepSeek. What do you make of that type of claim?
That's a great question, Chris. OpenAI is essentially alleging that DeepSeek utilized their API to get ChatGPT to answer a bunch of questions and then get a bunch of outputs. And then DeepSeek trained on top of those outputs to get a model that's as good as ChatGPT. And what they say DeepSeek did is they use this word called distillation, which is a very normal training strategy in the machine learning community. But the way that OpenAI uses this word is almost a pejorative. They're accusing DeepSeek to be a strictly worse version of ChatGPT that's been derived entirely from ChatGPT. And I find this unlikely for a variety of reasons. First of all, let's clear up the name of distillation. Distillation is a training strategy in which you take a large model and you try to distill certain components of it into a smaller model. We do this all the time. Like I train a very big model. I know that it's overly complicated and maybe not as efficient as it could be. I want it to run on a more constrained piece of hardware. So I'll distill that model into less parameters or into a different type of model entirely. Very normal, happens all the time, completely above the board. And normally in distillation, we actually need to have white box access to the teacher model, right? We call it student teacher, where your distill model is a student, your distillation model is the teacher, and we essentially have access to its weights that we're essentially copying periodically and in very smart strategies. Very, very high level explanation distillation. With the outputs that ChatGPT is providing, it's extremely unlikely that distillation is even possible. It's first of all very unlikely that I can span the support access of all the possible questions that one might want to ask DeepSeek or ChatGPT and get those outputs, because those outputs also vary every single time I ask that same question. And because ChatGPT is not exposing anything about its underlying model, like distilling that into something useful is going to be really hard. I've also seen no evidence from OpenAI that shows that this sort of systematic access happened from DeepSeek alone, because this pattern of training on another LLM's outputs is extremely common. Companies do it, academics do it. It's a very, very common access pattern. And so if OpenAI has like a unique set of data which demonstrated that DeepSeek somehow exceeded this sort of access pattern by orders of magnitude above what other people doing the same thing would have done, I'll be more inclined to believe their claim. But until now, that hasn't been substantiated. And the only thing that's been achieved is taking this nice word and concept of distillation and weaponizing it as a pejorative against DeepSeek. Whether they did it, whether they not, that's not a question for me to answer. But from everything that I've seen and the data provided in their paper and open source reproductions, it seems very unlikely that there was much of this impropriety going on that as OpenAI alleges.
And does this in turn raise questions about, of course, the Stargate initiative, right? $500 billion AI infrastructure, right? Has this gotten innovation wrong?
I think infrastructure is good. I think that in order for AI to grow, it will need more resources, but we don't just need those resources for LLMs. And I think that's the biggest distinguishing factor. Like, I am of the belief that LLMs are not the technology that matters the most when it comes to national competition. And if Stargate is only going to be used to help OpenAI and Anthropic and some of these other companies just make their LLMs bigger, I think it's a poor investment. If Stargate is used as an opportunity to invest in a multitude of AI technologies, not all of which are just LLMs, then I think it's a great investment because those resources are sorely needed. Unfortunately, my read of Stargate and everything that I've seen is simply that, is that it's supposed to make OpenAI and some of these other companies just train bigger models faster. And I don't think that actually gets us any further on the national competition scale. I do think that it reeks of prestige project. And maybe to rewind a little bit, if you look at China's 5-year plan that they update obviously every 5 years of like things that they want to do, 14 of the 15 things that they want to do are achieved without LLMs. And those types of models, like convolutional neural networks, let's say to do targeting or to do analysis of auditing Excel sheets or whatever, those require orders of magnitude less compute than what these LLMs require, and therefore are achievable without these large investments. So I just don't believe that like LLMs are the end all be all. They're not our way to AGI, and they certainly don't deserve more investment at the cost of taxpayer dollars. Instead, we might take those same dollars and invest them in talent and adopt a merger of the American and Chinese strategy and get further that way.
Right. So that being flooded with this investment, kind of right, billions of dollars, has in a way made the industry lazy, right? You can innovate just by throwing more money at it as opposed to nurturing the type of talent that purportedly has been nurtured in China in response to kind of a scarcity of GPU.
Yeah, Chris, I'm an immigrant and we grew up with this mindset, the scarcity mindset of like, we don't have money, we don't have resources, and we got to make do with what we have. And that forced my family to like be very creative and get better. And I think that's true of the world at large. Like if I'm in a world where I can just get another GPU and never have to worry about my terrible, inefficient code, I'll never rewrite my terrible, inefficient code. But if all I have is my crappy GPU and I have no other way to get another one, I will try to squeeze the most juice out of it. And fundamentally, I think that is a more scalable vision than infinitely scaling the amount of hardware and GPUs you have.
Interesting. And if we look at it from this perspective, does DeepSeek demonstrate that for countries that have been looking at the global AI race and feeling like they've missed the boat, that there is a lot more scope for entering in competition than some of the big players would have liked to have us believe?
I think so. Fundamentally, at the end of the day, it is a combination of both investment and talent. And if it so happens that India, which has been surprisingly missing on the global AI stage, tomorrow decides that we're going to invest all this money with the talent that we have indigenously on competing on the AI stage, with everything that's been open sourced and all the techniques that are made available, I do think that India could become a competitor on the international stage much faster than previously estimated because of all the goodness that's been released openly. And I think that's scary for a lot of investors who truly believe in American sole dominance. Whereas I think AI researchers who are in academia and some of these other places will agree that there's no such thing. Like American AI dominance is only a function of its investment, but that investment comes and goes, and there's no reason other players can't invest either.
And turning to kind of efforts to maintain U.S. dominance in AI, of course, you alluded to export controls earlier, talking about kind of scarcity and the shortage of GPU chips and this kind of disbelief on the part of some in Silicon Valley as to how China achieved this. I know you've written on export controls in the past and gaps in U.S. policy on this. Does DeepSeek demonstrate why export controls on hardware like high-end chips ultimately are not sufficient?
Yeah, so we had a paper that came out called Whack a Chip that was looking at the futility or supposed futility of these hardware export controls. And what we did in that paper months before DeepSeek came out was analyze state-of-the-art LLMs that were released by other PRC AI labs, like from Tencent and from Alibaba. And what we found in our investigation of these open repos was that Tencent was using some of these more advanced hardware optimization techniques, software distribution techniques to basically get better use out of older hardware. Now, of course, we also noted the fact that Tencent was also being really shady about the GPUs they had. They would sometimes go on the record and state how many H100s they have and then delete those references later. And so clearly, like, it wasn't entirely honest. But the larger point was that, like, they were getting a lot of gains out of worse hardware by just having better software. And what we argued in the paper was, if the American export control strategy is essentially to play whack-a-chip, right? As in, a new chip is demonstrated by the adversary to be useful, and then we go ahead and export control it, that's not a winning strategy. In fact, we're going to be continuously behind the curve because we only export control it once it's been shown to be useful, which means they've already stockpiled it, they've already made it useful. Like, what are we doing at that point? And so what we argue for is that a useful export control strategy needs to include hardware and the software that makes that hardware useful, and that combination needs to be export controlled. And the way to do that, one of the ways that we propose, is that we need to have continual benchmarks where hardware vendors who want to export their hardware will make available to a national AI safety lab, for example, their hardware in a data center for benchmarking. Academics and companies will be incentivized to then take their most cutting edge software techniques and train models against that hardware. And if any of those things are shown to be capable of something the US doesn't want to happen, then that combination of things should be export controlled. That's our proposal. There's a lot of people who argue that export controls will work, just give it time. I disagree, but clearly a lot of the things they're saying are also sensible. And I guess it just differs on like what your thesis is on how this innovation is happening. My thesis is they have very good software talent and they are able to build hardware faster than we're able to stop it. And the other thesis is that, they're not going to be able to build the hardware at the speed they need. And fundamentally, we are so advanced in our AI development that like they're never going to catch up, or at least the gap is so large that we'll be able to maintain it for a long time. You know where I stand, but just to also point out that there's another view which hasn't been disproven and hasn't been proven either, that's also simultaneously being pursued.
To be clear, what you're advocating is for us not to stop export controls on hardware, but to combine export controls on hardware with software.
That's correct, Chris. And I'm not saying we should ban software. What I'm saying is that we need to get to the heart of the issue, which is that the stated goal of American export controls has always been to stop the development of weaponized AI by our adversaries like China and Russia. The issue has always been is that we can never define what weaponized AI is. Is it a targeting model? Is it an LLM? It's able to do intelligence analysis? We don't define it. We just vaguely say it's weaponized AI. And so if we're able to better define what these negative use cases are according to the American point of view, then we're able to benchmark those accurately and then as a result control hardware. Like 3090s and 4090s and even the Instinct series GPUs from at AMD, I forgot what the exact gaming version of the AMD chips are, but like they work just fine to create SOTA LLMs. But the reason that we let them be export controlled is because we still want NVIDIA to be able to make money. But if we could very quantitatively say how good these GPUs are to train these specific weaponized AI capabilities, then we can make a smarter decision. And right now, because software isn't part of that conversation, we don't make a smarter decision. We just assume, and I think making assumptions is terrible.
Interesting. And some might suggest that due to the as you alluded to, the inherent dual use nature of kind of what is general purpose, right? That getting into software would bring you into kind of a realm where it would be very difficult to determine, as you mentioned, kind of what is weaponized, what is weaponizable, right? It potentially could catch a lot in that net.
Something the existing export controls do really well is control not just GPUs, but also their supply chain. right? The export controls do a really good job of stopping the export of EUV and DUV lithography machines to China. They're stopping the export of HBM, high bandwidth memory, to China, and TSMC semiconductors, etc. Similarly, I think that bringing software in will illuminate what is possible, but stopping software is a much harder and maybe Supreme Court illegal proposition. But what I think it will let us do is essentially then understand what supply chains we need to stop in order for those specific use cases to be stopped. So for example, if we find out that an NVIDIA 3090 is able to train targeting models really well, object detection models, then instead of banning RCNN, what we could do is ban the export of sensors that allow you to get the type of data that allow you to do targeting, right? So there's other things that we could do, I think, and be more creative with and really be more comprehensive with that prevent a lot of the loopholes that I currently see in the modern export control strategy. I think hardware is simply too broad of a hammer.
And speaking of being creative in U.S. responses to AI innovation in China, I see you recently published an article looking at one of the proposed responses on the part of the U.S. U.S. Senator Josh Hawley's proposed Decoupling America's Artificial Intelligence Capabilities from China Act of 2025. Can you tell us more about what your take is on this approach to addressing the challenge that China poses in the AI realm?
I'm glad you asked about that. I'm just going to call it the Hawley Bill. The Hawley Bill proposes to essentially stop the import and export of AI to and from China. And the way they do this is by essentially defining what counts as a Chinese entity of concern. And it says that if you try to import AI code from these entities of concern, that is illegal and punishable, 20 years in jail, $1 million fine if you're a person, things like $10 million if you're an organization. And if you export AI code to Chinese people or Chinese entities of concern, equivalent penalties. The issue is that AI and AI code bases are stateless. And what we do in this article in Lawfare that we put out is we show quantitatively that the major AI code bases that we rely on in both America and China are co-developed. Like the code that is in these repos are coming from Chinese and American authors simultaneously. And so let's say this bill is passed and I'm using PyTorch at OpenAI to build my models, and someone from Huawei commits some code to PyTorch and I clone the repo. That's an import. I just imported Chinese AI code. Theoretically, I should be imprisoned, right? Or vice versa. Let's say I put out, I'm an academic at Berkeley, which I am, and I put out my newest model on GitHub because I want it to be reproducible by the academic community. Well, a Chinese researcher from ByteDance, clones that repository on GitHub. All of a sudden, I have now committed an act of export of AI to the PRC. Clearly, neither of these should happen. And what this bill will effectively do is essentially destroy American AI innovation because it kills our access to key code bases that we rely on. China already has been investing in their own completely severed ecosystem. So China, for example, has MindSpore, which is their replacement to PyTorch. And their commits on MindSpore are almost entirely, I'm saying with the exception of maybe 10 commits from Chinese authors from Huawei. And so China can already live without our code bases. We cannot live without code bases that have been commingled with Chinese authors. And so it's stopping and basically building two different AI worlds is a suboptimal outcome for America. And if anything, we will only incentivize China to get further ahead by investing their talent into building some of these AI frameworks from the ground up for their new fledgling domestic AI hardware domestic base. And so hopefully this bill doesn't pass. I think it has a low likelihood of passing, but I think it will actually end up destroying American AI innovation rather than helping it secure some protectionism.
And in terms of alternatives, there are concerns. It's not just raised in the US, but for example, here in Japan, South Korea, Australia, about DeepSeek usage, prohibiting DeepSeek usage on government computers and such. What level of concern do you have when it comes to some of these privacy concerns relating to DeepSeek and also DeepSeek's extraction of data from this model?
If you are a government agency and you're working with controlled classified information, you shouldn't be going to chatgpt.com or chat.deepseek.com and typing in that data in the first place. It doesn't matter if it's American or Chinese. That shouldn't be the policy, right? You should be using a certified hosted capability by a certified vendor, which doesn't speak back to any servers that you don't want out of your control. And so, yeah, I mean, rightfully, we should be banning not only chat.deepseek.com from American unclassified computers, we should also be banning chatgpt.com. And the only way to access ChatGPT should be through a government secured Azure instance that makes sure that that data is not hitting ChatGPT servers either. Be as it may, because DeepSeek is open source, we've already seen vendors like Azure, vendors like Clarify and others host DeepSeek that are entirely detached from Chinese servers for American customers. And I think that's what's going to happen is you're going to see DeepSeek be offered more and more, and it's going to be really cheap and maybe even the preferable option at times compared to ChatGPT. And it's going to be done in a completely secure fashion because, again, the code is open source. Anyone can run it. You can run it on your computer if you want to.
This is really fascinating. I think we've got time for just one more question, though. And that question is, Ritwik, there have been a lot of surprises and developments in the AI space in recent years. If we're looking for the next big disruptive event in artificial intelligence, what should we be looking out for over the horizon?
I think that we are currently extremely inefficient with data. One of the assumptions that's been existent in the AI space for a long time, and it's been recently changing, is that the amount of data that we can get access to is almost infinite. Like people will keep on generating data, the internet will continue on being scraped, and then we can continue scaling our models to be bigger and better just infinitely. And even if that hypothesis is true, for all sort of quadratic scaling purposes, we simply can't just keep getting bigger and train for longer. We have to find ways to do better with the limited amount of data that we have. So I think the next innovations are going to come in exactly that type of data usage. How do we get more efficient with the way that we use our data? And I think we're going to see a lot of stuff happen in this space. How and what, I wish I could tell you, because then I would be the person making those innovations happen. And certainly I'm not going to go share my own research ideas on a public podcast unless I've proven them. But at least my work in the future is going to be demonstrating how you can get more with less data and therefore train smaller models to do better with even fewer data points.
Well, thank you, Ritwik, and thank you. You certainly have shared a lot with us nonetheless. Thank you so much for taking the time to join us once again. And for our listeners, that's it for today's show. Join us next time for another discussion at the intersection of law, society, and politics. Until then, stay human.